The Jacobian of the C1 transformation, TUV equaling GUV, comma HUV, is denoted by the JUV and is defined by the 2 by 2 determinant. So below here, the JUV means Jacobian, and these bars here on the side are what signify that we're doing a determinant. And this is the actual calculation of the determinant here. So look below, it says in the following exercises, find the Jacobian J of the transformation. So before we get started with this 379 here, I'm just going to write y in a slightly different way. This will help us when we're working on our partial derivatives. So if I'm just going to follow the pattern here, dx du, I'm going to write dx du here, and that's going to be the x function with respect to u, and that's going to be 3 over 2 u squared. And then we're going to do the dy du, and dy du is going to be negative 2v over u cubed. And that's why I wrote it this way here, so I could actually see that very clearly. And then I have dx dv, and that's here, and that's going to equal 0 because there's no v's in this, so that's understood to be a constant. So the derivative of a constant is 0. And then our last one is dy dv, and that's going to be 1 over u squared. I didn't want to leave it as u to the negative 2 when I'm writing it out. So now we have every piece of information we need for our Jacobian. So for our JUV, that's going to equal 3 over 2 u squared and negative 2v over u cubed, 0 and 1 over u squared. And we're going to take the determinant of this. And this means we times those minus timesing those. So that's going to be 3 2u squared times 1 over u squared minus negative 2v over u cubed times 0. Now this is going to go away because it's times 0. So we end up with 3 over 2. And then these u squareds also cancel here when I multiply. So I get 3 minus 2, or 3 over 2 minus 0, which is just 3 over 2. So there's our Jacobian of the transformation, which is this here, my x equaling u plus 2v, and my y equaling negative u plus v. Later on, we're going to use these transformations to help us integrate and set up integrals in an easier way. We have used these in the past, we just don't know it yet, when we've dealt with a polar form of integrals and also the u substitution.